So hello everyone, welcome back to my channel. So for this day we will summarize the chapter 3 of the networking one in NetAcad. But before that, we need to read the introduction of this chapter. Okay? So chapter 3, Network Protocols and Communication. So more and more it is network that connect us. People communicate online from everywhere. Conversation in classroom spill into instant message chat session and online debates continue at school. So new services are being developed daily to take advantage of the network. So rather than developing unique and separate system for the delivery of each new service, the network industry as a whole has adopted a developmental framework that allows designers to understand current network platform and maintain them. So at the same time, this framework is used to facilitate the development of new technologies to support future communication needs and technology enhancement. Central to this development framework is the use of generally accepted models that describe network rules and function. So within this chapter, you will learn about these models as well as the standard that make network work and how communication occur over a network. Okay, so we go to the summary of this chapter. Okay, so data network are system of end devices, intermediary devices, and the media connecting them. For communication to occur, these devices must know how to communicate. So these devices must comply with communication rules and protocols. TCP/IP is an example of a protocol suite. Most protocols are created by the standard organization such as the IETF or IEEE. So the Institute of Electrical and Electronic Engineers is a professional organization for those in the electrical engineering and electronic fields. So ISO, the International Organization for Standardization, is the world's largest development of international standard for a wide variety of products and services. So the most widely used networking models are the OSI and the TCP/IP models. So associating the protocols that set the rules of data communication with the different layer of this model is useful in determining which devices and services are applied at a specific point as data passes across the LAN and WANs. So data that passes down the stack of the OSI model is segmented into pieces and encapsulated with addresses and other labels. So the process is reversed as the pieces are de-encapsulated and pass up the destination protocol stack. So the OSI model describes the processes of encoding, formatting, at segmenting, and encapsulating data for transmission over the network. The TCP/IP protocols use a open standard protocol that has been endorsed by the networking industry and ratified or approved by a standard organization. So the Internet Protocol Suite is a suite of protocol required for transmitting and receiving information using the Internet. Protocol data units or the PDUs are named according to the protocol of the TCP/IP suite: data, segment, packet, frame, and bits. So applying models allow individuals, companies, and trade associations to analyze current network and plan the network of the future. So the chapter 2 is all about the different protocols interaction such as the HTTP, TCP, IP, and the Ethernet. So HTTP is an application protocol that governs the way of web server and web client interact. Then the TCP, so it is a transport protocol that manages the individual conversation. Then the IP, so it is responsible for taking the formatted segment from TCP. And the last is the Ethernet. So it is the network access protocol that describes two primary functions. Okay. Then also in this chapter, it tackles the different internet standards such as the ISOC, the IAB, the IETF, the IRTF, the ICANN, and IANA. So here's and and also in this chapter tells about the OSI model such as the application, presentation, the session, the transport, the network, the data link, and the physical. So here's the video of the different internet standard, and also the video of the different layer of the OSI reference model. Okay.
Welcome to Zero to ProTraining.com. In this video, we will talk about what is ISO, or International Organization for Standardization. The International Organization for Standardization is known as ISO. It is an international standard-setting body. It is composed of representatives from various national standards organizations. The organization promotes worldwide proprietary, industrial, and commercial standards. It is founded on 23 February 1947. It is headquartered in Geneva, Switzerland. It was one of the first organizations granted general consultative status with the United Nations Economic and Social Council. This allows it to participate in the work of the United Nations. The three official languages of the ISO are English, French, and Russian. The organization's name would have different acronyms in different languages. IOS is English and OIN in French. It adopted the short name, ISO, based on the Greek word meaning equal. The name ISO and the logo are both registered trademarks, and their use is restricted. The organization today, known as ISO, began in 1926, as the International Federation of the National Standardizing Associations. It was suspended in 1942, during World War II. In October 1946, the new International Organization for Standardization was created. The new organization officially began operations in February 1947. ISO is a voluntary organization whose members are recognized authorities on standards. Each member represents one country. ISO has 164 national members, out of the 206 total countries in the world. Members meet annually, at a General Assembly, to discuss ISO's strategic objectives. The organization is coordinated by a central secretariat, based in Geneva. A council, with a rotating membership of 20 member bodies, provides guidance and governance, including setting the central secretariat's annual budget. The Technical Management Board is responsible for over 250 technical committees, who develop the ISO standards. ISO's main products are international standards. ISO also publishes technical reports, technical specifications, publicly available specifications, technical corrigenda, and guides. Sale of standards are one of the funding sources for the organization. Thank you for watching. For more videos, please visit zero2protraining.com.
Welcome to Cert Bros. In this video we're going to be taking a look at the OSI model. So, what is the OSI model? The model is a theoretical stack of 7 layers that can be used as a reference to help understand how networks operate. The model was introduced to standardize networks in a way that allowed multi-vendor systems. Prior to this, you would only be able to have a one-vendor network because the devices from one vendor couldn't communicate with others. It's worth noting at this point that we don't actually use the OSI model. We use something called the TCP/IP model. The concepts are exactly the same, the layers are slightly different. So if we don't use the OSI model, why would we bother learning it? Well, that's because it's still referenced a lot when troubleshooting or describing network operations. Let's take a look at the layers starting from the bottom up. Layer 1 is the physical layer. The physical layer is the lowest layer of the OSI model. Its key responsibility is to carry the data across physical hardware such as Ethernet cables. Layer 2 is the data link layer. At this layer, the physical addresses are added to the data. This is the source and destination MAC addresses. Switches are located at this layer. The network layer handles IP addressing and routing. At this stage of the OSI model, the source and destination IP address are added. Routers operate on this layer. Layer 4, the transport. The transport layer of the OSI model adds the transport protocols such as TCP and UDP. TCP, for example, is used for error handling and sequencing to ensure no data is lost. This layer also adds the source and destination port numbers. Layer 5, session. This layer is responsible for establishing and terminating connections between devices. Layer 6, presentation. This layer formats the data in a way the receiving application can understand it. This layer is also able to encrypt and decrypt data if needed. Layer 7, application. This layer is where the application and user communicates. Application-specific protocols are used here, such as SMTP, if you're sending an email, for example. A really good way to remember these layers is simply, all people seem to need data processing. APS-TNDP. So to fully understand how this model works, you need to see a real-world example. Let's say you send an email. The data travels through the OSI model, adding and processing data on each layer. Now this process is called encapsulation. Step 1, the application layer. Outlook creates the data, the email you wrote, the email addresses, etc., etc., and gets ready to send it using SMTP, which is the Simple Mail Transfer Protocol. Step 2, presentation layer. The data is formatted in a way the receiving device will understand. In this example, probably ASCII. This layer could also encrypt the data if needed. Step 3, session layer. A session with a receiving mail server is started. Step 4, transport. This is where it decides to use TCP or UDP. In this case, we'll use TCP to make sure every packet gets delivered. Also, the source and destination port is added to the data. Step 5, network. The IP address of the mail server is added as the destination, and the source IP address is also added to the data. Step 6, data link. The MAC address of the router and the source MAC address of the host is added to the data. Step 7, physical. The data is sent out on the network using Ethernet. So when the data reaches the other side, the receiving device will process the data in the same way but in reverse, starting from the bottom up. Okay, so that's the OSI model, but how can we use this to troubleshoot? You may have heard the term, oh, that's a layer 2 problem, or sounds like a layer 3 issue. When you hear that, that's people referring to this model. Let's say there's a problem with the network. If we go through this model, checking every layer, we can soon diagnose the problem. For example, layer 1. Are all the cables plugged in? Is the network card functioning? Could it be a faulty cable? Layer 2. Maybe the switch has gone bad. Layer 3. Is the router functioning? Do I have the right IP address? And the process goes on and on from there. I hope you've enjoyed this video. If you have, remember to subscribe, comment, and give a thumbs up. Thank you for watching.
So that's all for today, and see you in my next video. Bye bye.